morning, students. After the theory, let us start with the example. Chapter number 5, example 1. If A, B and C are 3 points on the line, let us draw a line that we can understand better. It's a line, not a line segment, right? A, B and C. A, B and C. 3 points on a line, and B lies between A and C. B is lying between A and C. Prove that AB plus BC equals to AC. What we have to find? This plus this equal to this. That means AB BC equal to AC. This we have to find. Now in the question only they say B is a between A and C. Between, that means, yes, of course, it is after A and before C and exactly between. So we will say that we can use axiom number 4. What they are saying? That Euclid's axiom 4 says that the things which coincide with one another are equal to one another. Right? They are saying that this equal to this. So if they both are equal, then total will be equal. So we will say that from axiom 4, AB is equal to BC. So BC equal to AB. Here it is a proof, right? Both are equal, right? If you total it, that means, of course, it will be equal to the sum of both. Right? Now, question number 2. I mean, example 2. Prove that an equilateral triangle can be constructed on any given line segment. We have to prove that if you take any line segment, you can form an equilateral triangle. Now what is equilateral triangle? All sides and angles of a triangle are equal. Suppose 60, 60, 60. 5 cm, 5 cm, 5 cm. This is known as equilateral triangle, or we can say that all sides and all angles are equal. That is known as equilateral triangle. Now we have to prove that take any line segment and you can form an equilateral triangle. Yes, it is right. And how to prove? Let us see that. Example number 2. Suppose A and B. AB is a line segment and 22 cm. Measurement of. Now take a measurement to AB and fix it. Don't change it and form R. Form an R. The same Now, join the lines. Give the name C. Now, if you measure these two lines, you will get the same measurement. This way, if you take 50 centimeter, 9 centimeter, you will get everywhere 15 centimeter. If you take 1 meter, everywhere you will get 1 meter. So, according to the line segment, you can form equilateral triangle using a rounder. So, this is the example number 2. Now, theorem 5.1. Two distinct lines cannot have more than two distinct lines cannot have more than one point in common. They are saying that we have to accept. Right? Theorem, that means we have to accept. Suppose A and B both are distinct lines. A, B, C, D, or A, B, C, D. Now two lines only if they interact, two distinct points, if they interact, only one possibility. At a one point only they can interact, not more than one. If you form any other angles, you can see that only two lines can interact only one point, not more than that. That we have to accept. Right? Now, exercise 15.1. So, which of the following statements are true? And write the reason also of the question. True and false you have to do, and you have to mention also a reason. Let us discuss the exercise 5.1. Only one line can pass through a single point. Only one can. Exercise 5.1. Question number 1. Sub question. A single point is there. Name is O. So they are saying only one line can pass over one point. One line, name is L. Another line M. Third line N. Fifth P. So here it is a wrong, because from the one point infinite lines can pass. So question is false, and you have to draw the diagram as an example. Example shows that from the one point infinite lines can pass. Now second, there are an infinite number of lines which passes through two distinct points. Now they are asking 2 points, A and B, 2 points. Now let us pass one line. Name is L. Now from these 2 points cannot pass any other line. Only one and only one line can pass through two distinct points. So this is a wrong. This is the reason why. So if you try to form the same from the same points, you will get the same line. There is no other line. Question number 3. A terminated line can be terminated line can be produced infinitely on the both sides. what they are saying, terminated line can be produced infinitely both the side. Yes, it is according to the postulate 2. Postulate 2, what is it? Postulate number 2. We can produce line segment through we can produce a line through the line segment, so it is true. Question number 4. If two circles are equal and then the radii are equal. 4. Suppose circle 1. I will not change a measurement for another circle, fine? We have to form two equal circles whose centers are E and Q. If both are equal, then distance from 0 to any other points are equal. Q to A, P to A. So distance from P to A and Q to A are equal. So all the radii. So all the radii are equal for two equal circles. Question number 5. In figure 5.9, if AB equals to PQ, PQ equals to XY, and then AB equals to XY. So it is similar to example 1. Right? It is similar to example 1. So you can say yes, it is like that only. So you can write it by yourself. Now question number 2. Give a definition for each following term. Are the terms they need to be defined first? What are they and how might we define them? They are asking from the theory. Right? They are asking from the theory. That how we can define. First is parallel lines. It is a parallel lines like L, line M. They are saying parallel lines. So we can say that parallel lines can never intersect each other. Parallel lines can never intersect each other and the distance between both the lines are equal. If you form one line like here and one here, that is not a parallel line. They are not intersecting, but the distance between both are not equal. So the parallel line like this way, this way, this way, this way. So it is a example of parallel lines and that can never intersect and distance between the lines are equal. So this statement you have to form like this way. Now question, perpendicular line. What is perpendicular line? Definition number 2. A line. A line formed right angle on another line and formed right angle on N or N formed right angle on N. It is known as they are perpendicular to each other, or L is a perpendicular or N is a perpendicular. So in short, the angle must be a right angle. Then only we can say that they are perpendicular. Then line segment. Line segment, terminated line which is not infinite, is known as a line segment. Radius of a circle. Radius of a circle. This is known as the radius. So how we will write the definition? Distance between center and any other point. Center and any other point on the circle is known as radius of a circle. Otherwise, on the circle, take any point and go towards a center. This distance is known as radius of a circle. In the square, a union of a line segment. Again I am repeating, square, that means a union of a line segment and their measurements are equal is known as square. Union of line segment. How many line segment? 4. 1, 2, 3 and 4. The union of a 4 line segment and the measurement of each line are same. It is known as a square. Right? So this way you have to give an example, and according to the example you have to write a statement. Now question number 3. Consider two postulates given below. Okay. Consider consider two postulates. First is, given any two distinct points A and B, there exists the third point C which is between A and B. Now we have to form a diagram in this question, or you can also give the statement even if you know how to give. Yes, what we will say? Yes, according to the postulates, if two terms are not explained, that means it is a postulate from the axiom, not from the postulate, it is from the axiom. You can also write. We cannot describe that point, surface and line. It is given in the theory. Second, there exist at least 3 points that are not on the same line. Do this postulate contain any undefined term? Are these postulates consistent? Do they follow from the Euclid's postulate? Explain. That two two questions we have to explain according to Euclid's. So in the both case we will say yes. According to the postulate, we can find out that if A and B both are in a line and C is a middle line, that means middle point, that means they all are in line. Yes, of course. And the second also, yes, it is like this way because AB is a line and A and B both are between the A and C. So it is also in a line. So here question number 3 is finished. Now question number 4. If a point C lies between 2 points A and B such that AC equals to BC, then prove that AC 1/2 AB explained by the drawing figure that I already explained to the example number 1. If half is equals to half, then we can consider total is equal to the half also equal to the one segment. Fine, so that I already explained in example 1. Now question number 5. In question number 4, point C called a midpoint of a line segment AB. Prove that every line segment has one and only one midpoint. Now we have to prove that if you are considering any one line, name given A, whatever you are giving, no problem. But only they have only midpoint, only one, of course. How we have to go? We have to walk on the same line both the sides with us simultaneously, and where you will reach at the point is equal, where this fellow cannot pass that point and this fellow cannot pass that point. That means it is a center of a line, or we can say it is a midpoint of a line. So how we will solve according to the example 1. Suppose A and B. Now I will start walk towards B, and here I will start walk towards A. So simply at the point they will meet together, right? So and let us give the name C. Now you see that AB equals to AC plus CB, or we can say that AC equals to 1/2. So this way we can say that yes, it is a right. Only only one and only one midpoint. Every line has only one midpoint. Now question number 6. It is also like the 5th one. It is given that if AC equals to BD, then prove that AB equals to CD. You can prove by yourself according to this question. And the last question 6. Why axiom 5 in the list of Euclid's axiom consider it a universal truth? Why it is a universal truth? What they are saying? They are saying that what we proved in a question number 4, because if there is a midpoint in the line, that means both the part of lines are half of full. That's why it is a universal truth. So now exercise 5.1 here is really finished, right? That you have to write in your fair book. I already gave your fair book back, so that you have to form by yourself. And if you have doubt, you can ask me according to the explanation that I gave you how to send a doubt to me. Okay, thank you.